All right, so we should note that some reactant will be left over at the end of a chemical reaction. So basically, the reactant used up first in a reaction is called a limiting reagent because the maximum amount of product formed depends on how much of this reactant was originally present. When this reactant is used up, no more product can be formed. So therefore, excess reagents or the reactants present in quantities greater than necessary to react with the quantity of the limiting reagent. So let us consider industrial synthesis of methanol from carbon dioxide and hydrogen at high temperatures. Suppose initially we have 4 moles of carbon monoxide, 4 moles, and 6 moles of hydrogen gas. One way to determine which of two reactants is the limiting reagent is to calculate the number of moles of methanol obtained based on the initial quantities of carbon monoxide and hydrogen. So from the preceding definition, we see that the only limiting reagent will yield the smaller amount of the product. So starting with 4 moles of carbon monoxide, we will find the number of moles of methanol. So 4 mole CO multiplied by 1 mole. So there is 1 mole methanol, 1 mole uh, CO. So therefore, 4 mole of methanol. And while starting with uh, hydrogen, we have 6 moles. Again, 2 moles of hydrogen is stoichiometric equivalent to 1 mole of methanol. So cancel. So we will have 6 divided by 2, 3 moles of methanol. So because hydrogen results in a smaller amount than this one, smaller amount of methanol, so it must be the limiting reagent. Therefore, carbon dioxide is excess. Okay. So let us try to make an example. Let us try to solve some examples. So there you go. Urea is prepared by reacting ammonia with carbon dioxide, 2NH3 plus CO2 and H2 urea, which is CO aqueous plus water. All right, in one process, 637.2 grams of ammonia are treated. 637.2 grams are treated with 1,142 grams of carbon dioxide. So let A, which of the two is the limiting reagent? B, calculate the mass of urea formed, and C, how much is the excess reagent in grams left in the reaction. So basically, what on the first question, we need to identify which is the limiting reactant. So from the given uh, masses of the reactants, we can compute for the number of moles of urea. Okay. So first, we'll try NH3. So 637.2 grams. Uh, NH3. How many grams of NH3? I mean molar mass. 1, 7, 17.03 grams NH3. 1 mole NH3. And there are 2 moles NH3. 1 mole urea. H2, 2CO. So therefore, cancel, 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 cancel. So therefore, we will have 18.71 mole NH2, 2CO. While if we'll try to use now carbon dioxide, 1,142 grams CO2, 44.01 molar mass, grams per 1 mole CO2. So 1 mole, 1 mole, 1 mole CO2, 1 mole urea. Cancel, 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 cancel. So therefore, how many grams of urea are formed with 1,142 grams of carbon dioxide? So it has 25.95 moles. NH2, 2CO. So therefore, we can conclude that the limiting reagent is this one because it has a smaller amount. So therefore, the limiting reagent is NH3. Okay. So since we already know uh, the limiting reagent, so let us take note on this one. So LR is 18.71 moles. NH2, 2CO. So we will use this one for us to be able to calculate how much. So how much is the urea that is produced? How much urea is produced? So, okay. So the answer in question in letter A is this one, ammonia. So in letter B, so we have here, we will use the limiting reagent because it's the first one that will be used up. So basically, ito yung nauubos, unang nauubos para ma-produce ito. So ito na yung excess reactant. So 18.71 moles. That's the reason why we will use the value of the limiting reactant. Kasi nga siya yung nauubos, unang nauubos. Multiplied by molecular weight, 1 mole of urea is how many grams? 60.06 grams NH2. C CO. Cancel. Cancel. So therefore, the mass of urea produced is 1,124 grams urea H2 CO. Okay, so we will proceed and we'll answer letter C. So how much excess reagent is left in the reaction? So we will use this value again. So how much CO2? So mass of CO2 used. Kasi yun lang yung nagamit. So 18.71 mole NH2 CO multiplied by 1 mole NH2 CO 1 mole 1 mole CO2 in 1 mole CO2 there is 44.01 grams CO2. Therefore, how many grams of carbon dioxide is used? It has 823.4 grams CO2. So, therefore, the excess reactant is 1,142. This is the starting material, no, yung given natin minus yung nagamit 823.4 grams is equal to 319 grams. Okay, so we have here another example. The reaction between aluminum and iron 3 oxide can generate temperatures approaching 3000 degrees Celsius and is used in welding metals. In one process, 124 grams of Al are reacted with 601 grams of ferric oxide. So let's try to write first the equation. L So we have here 1,124 grams, and we have here 601 grams. So the question is A, calculate the mass of Al2 or aluminum oxide formed, and B, how much is the excess reagent left. Okay. So first is we will uh, identify which reactant is the limiting reactant or limiting reagent. So by doing that, we have here 124. We'll try to identify first the limiting reagent. 124 Al. So in 1 mole of Al, we have 26.5 98 grams Al. And according to our equation, 1 mole of aluminum oxide formed. Stoichiometry, there is 2 moles of aluminum reactant are needed. So we will have 2.29.78 moles of Al2O3. Okay. So we'll now try to check the ferric oxide, grams Fe2O3 in 1 mole of Fe2O3. We have 159.69 grams. And we have 1:1 ratio. Cancel, cancel. So after, so 601 divided by 159.69, we will have 3.7635 moles of Al2O3. So therefore, we have here the smaller amount of aluminum oxide. So therefore, our aluminum is our limiting reactant. And this is one is the excess reactant. So I'll take note the limiting moles is 2.2978 moles of Al2O3. Okay, so from there we will be able to calculate the mass of aluminum oxide that will be formed in our reaction, our chemical reaction. So therefore, 2.2978 moles of Al2O3, 1 mole Al2O3, it has 101.96 grams. So what is left is grams. So therefore, we have 234.34, oh, I'm sorry, 304 grams of Al2O3. Okay. So we will now solve for the excess reagent. Okay, just write here. The answer is 234.304. Okay. So since we've already know uh, what is the excess reagent, we'll now be able to compute for the amount. So again, we will use the value 2.2978 kasi siya yung unang nauubos. O basically, bakit natin ginagamit yung 2.2978 moles aluminum oxide? It is because ito yung na-form niya na with this one. Naubos na siya. After naubos nito, ito na yung na-form niya. So, okay. So, we have 1 mole Al2O3. We have 1 mole as well 1 mole FeO3, 2O3. It has 101.96 grams. So, ang sagot ay 383.726 grams Fe2O3. So this is the amount of ferric chloride that has been used or consumed. But we should take note that our our starting material is 601 grams. So basically, meron tayong sobra. So excess is equal to 601 minus 383.726 is equal to 217.27 grams of Fe2 or ferric oxide. It is the excess amount. So we will now proceed to theoretical yield or reaction yield. Theoretical yield is the reaction. Is the amount of product that would result if all the limiting reagent reacted. That theoretical yield then is the maximum obtainable yield predicted in or by the balance equation. The actual yield or the amount of product actually obtained from the reaction is always less than the theoretical yield. Okay, so theoretical yield, basically it is based on chemical equation. But the actual yield is the actual amount obtained during a process. So we'll try to solve some examples. Okay. So to determine how efficient the reaction is, chemists often figure the percent yield, which describes the proportion of the actual yield. Okay. So it is a percentage yield over actual yield over theoretical yield times 1000. Okay. So we have here an example. Titanium is a strong, lightweight, corrosion-resistant metal that is used in rockets, aircraft, jet engines, and bicycle frames. It is prepared by reaction of titanium 4 chloride with molten magnesium between 950 degrees Celsius and 1150 degrees Celsius. So we have here TiCl4, solid magnesium chloride, dichloride. So in a certain industrial operation, 3.54 times 10 raised to 7 grams of titanium chloride are reacted with 1.13 times 10 raised to 7 grams of magnesium. Calculate the theoretical yield of titanium in grams, and then B, calculate the percentage yield of uh, 7 if 7.91 times 10 raised to 6 grams of titanium are actually obtained. So we have here 3.54 grams times 10 raised to 7. And we have here 1.13 times 10 raised to 7. So our unknown is a theoretical yield. of the titanium. B is percentage yield. Theoretical yield, from the word theoretical, so it is based or estimation based on the chemical reaction. So, okay, let's try to solve. So we'll try to use this one first. 3.54 times 10 raised to 7. So per mole of titanium 4 chloride, we have 189 grams, 0.7. And we have the relationship 1 is to 1. So 1 mole TiCl4, 1 mole as well. So therefore we have 1 is to 5. Okay, moles Ti. Okay, so we also have need to check if, I mean, who is the limiting reactant? Is this one or this one? So we have here 1.13 times 10 raised to 7 grams Mg magnesium. So in 1 mole Mg or magnesium, we have 24.31 grams. And we have here, we have 2 moles Mg, 1 mole of titanium. So cancel, 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 cancel. We have 2.32 times 10 raised to 5 moles of titanium. So, therefore, uh, titanium 4 chloride is our limiting reactant or reagent because it produces a smaller amount of titanium. Okay, so we'll take note our limiting reactant. This is our LR with 1.87 times 10 raised to 5 moles of titanium. Okay. Alright, so we will now be able to solve for the theoretical yield of titanium that is formed based on the equation. So 1.87 times 10 raised to 5 moles. In 1 mole of titanium, we have how many grams? 47.88 grams. So therefore, our or the theoretical yield for this one is 8.95 times 10 raised to 6. Again, the theoretical yield is the amount or the estimated amount that is produced based on the chemical reaction. No? So we will now be able to, after that, we will now be able to calculate for the percent yield. Okay? So we are given the amount of of 7.91 based on our problem. We have here the actual yield or the actual amount that is obtained is 7.91 uh, times 10 raised to 6 grams of titanium. It's not uh, the 8.95. The 8.95, okay, which is the theoretical yield, sabi ko nga, it is the estimated amount based on the chemical reaction. But the actual yield, which is based on the actual process sa industry, is 7.91 times 10 raised to 6. So we have here 10 raised to 6. So the percentage yield is computed as follows. Yield is the actual yield over the theoretical yield, which is actual is 7.91 times 10 raised to 6 over 8.95 times 10 raised to 6 multiplied by 100 kasi we are dealing with percentages. So therefore, percentage yield is 88.4%.